And today we'll have a quick look at building a vapour chamber for your 3D printed models. Some of you may actually like to vapour treat your ABS prints if you're into 3D printing. One of the benefits of doing this is that you actually kind of bond the bits of ABS together, the different layers that can often break apart at their area where the layers meet. So the idea with this is that you will put your component into the vapour chamber. You'll have some acetone in here. Be aware acetone is dangerous, but that's still got acetone in there. I'm surprised it's still wet. We would sit this into the airtight container, and then what we'll do is heat up the acetone to about 65 degrees Celsius, and we'll actually start to see the acetone vaporize off. In the bottom here I've got a bit of towel that is soaked in acetone. The acetone will vaporize off and actually form a little vapor cloud inside this jar, which will get the acetone all over the 3D part. Probably watched, if you're interested in this, you've probably watched a number of videos on YouTube already. So we can lift that out, and the part will be then nicely joined together, and it really does make these little ABS parts much stronger, watertight, even airtight, and it gives you a really nice smooth finish when these bits have been treated. Now, one of the problems I've got is my acetone vapour chamber that I've been building is not big enough to take some larger parts. I'd like this to be much larger, really. It's a little VR headset that I've been working on. So I'm going to look at building a much larger unit today. So we'll follow this through maybe in a couple of parts, put it together and do some tests. I've had a few ideas of what I'm going to do, and I'll discuss those probably during part 2 of this tutorial. But essentially this glass jar is going to go. A couple of warnings. Acetone is a solvent, so do be careful with it, use it in a well vented area. You do not want to reach the flash point of acetone. I'm not entirely sure what the flash temperature is, but that means that, you know, if you get it too hot and you introduce air, it could combust on its own, spontaneously combust. I will make sure that any heating that goes on, now usually I put this on my 3D printer heat bed and I will heat it up to 65 degrees, and that's more than hot enough. You really do need to make sure that you're keeping an eye on the temperature of this, that this doesn't get too hot. The last thing that you would want is a large glass container like this exploding. It would essentially turn into a glass frag grenade, which would not be good at all in your workshop or your bedroom or wherever you're doing this. The other thing to be aware is I don't believe acetone's very good for you as a solvent. I know in places like nail salons they use it a lot, and I've heard girls and women telling me that they've sat there and it's stunk of acetone. It's not as bad for you as some solvents like spray paint solvents and that sort of thing, but you definitely want to be in a well ventilated area. I'll have the windows open. When I take this out, I try not to take a deep breath of the vapour escaping from the container. Just common sense, really, other than that. So some of the things we're going to need for this project are a new container. Now, I've actually dragged this over, found a nice container here. It's quite large, dragging it over, here we go. This is a nice large glass container here. We do have a screw lid, you can barely get it all in the shot there, it's so big compared to the other one. Let's actually place the other one up there for comparison. Much larger. Okay, now this is the jar I will be using. Will my large component fit in there? Go on, please say it will. Oh yeah, look at that. Oh. Doesn't quite. I reckon I could get that to fit in there though, with a small modification. go on. We'd get that to fit, no problem. I will get a pair of snips. This little bit here that kind of goes around the side of the face, I could get rid of one of those on one side, yeah. Chop that bit off the other, and I can just file that down eventually, so that it's a little bit more ergonomic. Go on, there we go, so now that will fit in there. So that's the piece I'm looking to vapour treat, which will now go in and out fine. Now you may notice there is actually a hole in this jar. These jars are quite useful with the hole in. What this one was intended for was as I believe a punch jug, or it had a tap like that. You fill this up with your punch, alcoholic, non-alcoholic, whatever you like. Then you've probably not fizzy, because fizzy would make that come out at some force. We've got a nice little tap on it. For this job I'm just going to take that tap. I'll say throw it away, but actually it will go into stores, because who knows when you might want a nice little plastic chrome tap like that. It's quite cute really. So we'll keep hold of that in stock. Also we've got our lid. Now the hole may not be beneficial for this particular project, but what I plan to do is put some wires through there. I'm actually going to have a little fan that circulates the vapour inside here. Possibly a temperature sensor, probably not needed. The other things we're going to want is, of course, something to apply heat with. So I did recently get a kit, and it came with a heat bed. Nice cheap kit on the interweb. Came with a nice heat bed. I don't actually need the heat bed from the kit, so I'm repurposing it for this. So somehow I'm going to have to mount the heat bed to the bottom of this jar. The next thing I'm going to need is some sort of power system to actually power this up. I do believe the heat bed needs quite a bit of current, so I will be using a old PC power supply. This is one that has given up working properly for me, but it does actually still produce voltage on the main power output. Is this an ATX or a new type of ATX? But I do get some good voltage and current out of there, so I will be modifying this power supply to provide the power for this heat bed. The last thing we will need, I have got a little temperature controller here. You get these online, very cheap, couple of £2. Got a little display on there. You can either use it for cooling or heating. It's got a nice little relay on board. The relay does say 20 amps. I believe 20 amps, 14 volts, which should be more than enough for this particular. I'm not actually sure what ampage these use, but I could do a bit of Ohm's law and figure that out, but I can't really be bothered. I'm just going to hope that the relay is beefy enough for the job, and if it's not, it will just melt. We'll need, there's some other things that come with this circuit that I just can't seem to put my hand on right now, such as, here we go, a little temperature sensor. I'm going to have to somehow mount this temperature sensor onto the heat plate. That's going to be essentially all of it, I think. I'm going to put a small fan inside the jar, so we're going to need a fan. The last thing I've got is this like little mini, what would we call this, a quiche tin, a tart tin. That's going to probably go in the bottom and just be a general upgrade from that jam jar lid that you saw at the bottom. I'm going to have to somehow make a little metal pair of hooks that hook on there that will allow me to remove the part from the jar. Once the fan and any other electronics have gone through that hole, I'll probably block that hole up with a little 3D printed bung. Will that work? Not ABS, because that would of course melt, but maybe PLA, because PLA doesn't actually react to the acetone vapour. So I put a little bung in there, and that should just give me enough hermetically sealing properties. How would you say that? Make it airtight, basically. Possibly could even act as a safety feature, that if pressure built up too much it would just blow the bung. We all like a bung to blow instead of a big glass jar exploding, which is never that fun. Believe me, I've had it happen when messing about with hydrogen fuel cells in the shed a couple of years ago. Luckily didn't get me with the glass, but did hear it from inside and thought a lorry had hit the house and found lots of bits of glass everywhere. So let's try and avoid that from happening at all costs. So that's basically what you're going to need to start this project off. We will continue with part 2 soon. Okay, so a little bit continuation of where we were at with this project. I've got my heat plate. I've soldered on the connectors on here because it's set up as a 12 volt system. I'm going to be using red to number 1 and ground to 2 and 3. Just soldered a little link on there. Probably not good practice, but I've actually just glued the thermistor from this little heat controller. I believe it's a thermistor and not a thermocouple. Straight down to the heat pad. Now I've seen a few mixed reviews on this stuff. I've actually just used this 5-second or 10-second fix to glue it on. You use like a liquid polymer there and then a bit of UV to set it. Could have used super glue, but I do find super glue is very brittle. People have given mixed reviews about how well this stuff sticks, but I do find this sticks better to some things than other glues. So for example, I've been trying to glue stuff to glass and this works very well, much better than super glue. But I do have a large array of glues. It's the best solution in the right place sometimes. So I've been thinking about how I'm going to isolate this heat plate thermally from the surrounding area. Obviously on a 3D printer it's kind of hovering in air, and then you've got some sprung suspensions that actually stop everything from getting hot. So I was going to go for a similar kind of affair. I've got a bamboo cutting board here that's very cheap from the local hardware shop. I'm also going to use a baking tray under there as well. The baking tray should act as a bit of a heat shield and also to reflect some of the heat back, so not so much as escaping straight down into the wood. I think the wood would probably do it itself. The other thing, of course, I'm going to do is put some air gaps in, so I'm actually going to raise that up. I was thinking I could 3D print some little pillars for it to sit on, but I actually found in stock these little plastic feet. I don't know how these plastic feet respond to heat. We'll just heat one up a bit there. They do go soft. Okay, they do go soft. Hopefully they won't go soft at 60 or 70 degrees. If I use the ABS is really good up to about 150, 160 degrees before it loses its integrity. It doesn't melt on the heat beds that go up to 120 degrees Celsius, certainly. The other option is to use nylon. I could use some metal there. I'm going to use a nut and bolt to hold it down, but the idea is that this plastic should help insulate some of the heat from the surrounding area. So let's start off by mounting this. I should probably centre punch these holes. I'm not going to. 1, 2. Let's try and make sure that one stays on point. 3, and the final one, 4. Well, it's been under test for a little while now. I've actually increased the bed temperature up to about 85 degrees to try and get a bit more heat into the jar. Put a little bit of water in there. Just check that it actually heats the water up, and it worked quite well. So what I'm actually going to go ahead and do is an acetone test now. I've decided to cover that hole up. I had a go at putting some tape around here to see if I could get more thermal energy up into the glass. It didn't seem to help, but what I did notice is even though the water was only getting up to about 40 degrees, it was creating a lot of vapour and the jar filled up with condensation. So hopefully this time it's going to work. I've gone ahead and made this little contraption here. This is that little pie tin or quiche dish that we were looking at. Bit of piano wire, folded up, and that should just fit in nicely. Probably not the best. I was going to try and glue those into place, but the problem with this being Teflon coated is that nothing wants to stick to it. Yeah, that should work. Right, so next step, very careful, we're going to use the acetone. I've got plenty of ventilation in here, got a vapour mask on, we'll be wearing a vapour mask. And I'm just going to put a small amount of acetone in, that will do. Just a little dash, probably about a couple of teaspoons. I'm going to put this little model on there that came with the 3D printer that I acquired. Sit that inside. Put the lid on. The lid doesn't actually have a seal in it as such, so I don't know how good this is at creating an airtight seal. What I will do is I've got a little sheet of neoprene. I will probably laser cut that and put a little gasket in there. But for now I'll just screw that on. There we go. And can I see the acetone at the bottom? There is a small amount of acetone at the bottom. And then we'll just leave that for some time and see how it goes. So it's been in there just about a minute or so now. You can actually see the bottom of the glass is misting up here, so we've got vapour being formed. Get a nice view of the squirrel. Well, you can see just after a minute or so it's quite frosted in there, quite steamed up with the acetone vapour. Just going to leave it in there for a few minutes. When I've done this before, you'll normally see the parts start to look shiny, visibly look as if it's covered in wet paint or varnish. Now this particular ABS I've used, the grey ABS in this case, I'm not sure of the quality, it could be mixed with some other materials. But we'll let that go in the vapour for a while. I think I left it for about 20 minutes and after that took it out carefully because it is soft and tacky after it's been in there, and left it on the windowsill for a few hours just to kind of vapour off and go hard. And then what I've done is given it a couple of coats of chrome spray paint here, which looks not too bad. Left that for a while to dry. Put it on my 3D printer turntable here, which spins a bit quickly, but we've slowed that down by taking a high speed shot at 240 frames. There is a bit of texturing left, but that's actually due to the original model, which kind of was not a smooth model. It actually had some texturing to kind of imply the fur on this squirrel. Not my model, came with a 3D printer on its SD card and it was just the first thing I printed.